encourage you to watch this video, and I'm going to go through a similar problem here on the next few slides. So the problem I'm looking at here is finding molecular and empirical formulas. So what we're talking about here is we have this question: find the molecular formula and the empirical formula for eugenol. Eugenol is eugenol has a molar mass of 162.2 grams per mole. That's its molar mass. And here's its percent composition information. So 73.14% carbon, 7.37% hydrogen, and the remainder is oxygen. So the first thing we're going to do here then is find the empirical formula. And there's a little poem some of you may have learned about how to find the empirical formula from percent composition data, and it goes like this. Change the percent to grams, grams to moles, multiply, divide by small, and multiply till whole. Well, let's go through that. Here we see that I've simply changed these percentages of carbon, and I've said, well, okay, if we had a 100-gram sample, out of that 100-gram sample, 73.14% would be carbon, so we're just going to call that 73.14 grams out of that 100-gram sample. And we do the same thing for hydrogen and for oxygen. So we just change the percent to grams. Then we're going to change those grams to moles, and you're really familiar with how to do that. Just do this unit conversion. And so we end up having here just a little more than 6 moles of carbon. I've carried out the sig figs here in this intermediate step quite a ways. We have 7.297 moles of hydrogen, 1.218 moles of oxygen. So the poem goes: change percent to grams, grams to moles, divide by small. So we find the smallest one of these moles, and we divide everything by that smallest. So that's going to be 1.218. So we divide everything by 1.218. So we have the moles of hydrogen. We're going to divide that by 0.1218. We have moles of carbon. We're going to divide that by. So we've divided everything by the smallest. Percent to grams, grams to moles, divide by small, and then we're going to see what we get here. If we get something that's like 1.5, then we have to multiply until there's a whole number. That's why the last line of the poem is multiply till whole. So what are we going to get here? Well, we get 5 and 6 and 1. Now, remember what this is telling us? This is telling us that in the formula of this compound, there are 5 carbons, 6 hydrogens, and 1 oxygen. So that gives us the formula in the lowest whole number ratio. So C5H6O is the empirical formula. So we're going to take this on to the next slide then. We're going to write C5H6O. C5H6O. That is the empirical formula. The lowest whole number ratio. And let's just find the empirical formula mass. So we have 5 carbons, 6 hydrogens, and 1 oxygen. So that's this is 16.00, this is 6.06, And get my calculator turned on here. I should know what 5 times 12 is. That sounds like 60, doesn't it? And actually, I probably should use 12.01. So 60.05. And we add that together. And we get how does 82.12 look? Does that look about right? Okay. That's the empirical formula mass. Now, we were given in the problem, I'm just going to switch back a slide for a moment to catch this number. We were given the molar mass of this compound, 162.2 grams per mole. So the molecular formula mass is 162.2 grams per mole. Now, remember the relationship between the empirical formula and the molecular formula is some small whole number relationship. So in this particular case, we can find that relationship by dividing both of these by the smallest. That ratio is 162.2 divided by 82.1. Did I make some kind of mistake here? I'm just glancing back. Okay. And we're going to be fairly close here with this. When you do this calculation, 162.2 divided by 82.1, and you can see where this is headed if you use your calculator right. What did my oh, I multiplied. That's what the problem is. Got to be careful not to do that. Divided by, and I get 1.98, which is really fairly close to 2, 1.98. So our ratio is of molecular formula to empirical formula is a ratio of 2 to 1, which means our molecular formula is just twice that of our empirical formula. So the molecular formula is C10H12O2. So if you watch the other video I was mentioning, it will show you another example, doing the exact same problem actually in a very different way. So you can watch both of those and see which one you think makes the most sense to you. So we'll look forward to seeing you on Wednesday, and be sure you come prepared with your calculator, pen, paper, pencil, all of that kind of stuff, and we'll look forward to giving you a short test. I think there are only maybe 7 problems on the test, or 7 questions, but it's probably going to be of the level of difficulty of this problem right here. Not necessarily impossible for you to get 100%, but hopefully you'll find it challenging enough that you'll go, yes, this was worth taking the time to study.